Hello everyone. In this video, we are going to discuss about algebra of real functions and example number 16 from the chapter 2 Relations and Functions class 11 Max. See, in this section we will be discussing the addition of two real functions, subtraction of a real function from another, multiplication of a real function by a scalar means a real number, multiplication of two real functions, quotient of two real functions, that is the division of two real functions, and also the example number 16. So let us see what is this addition of two real functions. Suppose we have two functions f and g, where f is from x to r and g is also from x to r, and x is a subset of the real number. Okay, real number set. Here we want to define the addition of two real functions, that is addition of f and g, that is we want to define f plus g, which is also from x to r. It is defined by f plus g of x equals, that is addition of two real functions is defined by f plus g of x equals f of x plus g of x for all x belongs to capital letter X, which is a subset of the real number set. See, don't worry about this definition. Let us do one numerical question that will give you a clear idea about this. Okay. So, let f is a function from x to r and g is a function from x to r. Let these two be any two functions where x is a subset of the real number set. Then we define f plus g of x from x to r as f of x plus g of x for all x belongs to the. So let us do one question. This is from the example number 16. Let f of x equals x square and g of x equals 2x plus 1 be two real functions. Then find the sum of these two real functions, that is f plus g of x. Okay, see, f plus g of x, that is the addition of two real functions, that is defined as f of x plus g of x. Okay, what is f of x? F of x is x square, g of x is 2x plus 1. So, this is the answer. Okay. Now, the second one is subtraction of a real function from one another. So, let f be a function from x to r, g be a function from x to r, where x is a subset of the real number set. Then, we define f minus g, which is the subtraction of two real function from x to r, by f minus g of x equals f of x minus g of x for all x belongs to x. That is, for example, let us consider this f of x as x square and g of x as 2x plus 1. Then what about f minus g of x, which is a subtraction of a real function from one another? Difference, no? So f minus g of x is defined as f of x minus g of x. Okay, f of x is x square minus g of x is 2x plus 1. So, when we open the bracket, we can write it as x square minus 2x minus 1. This is the answer. Okay. Now, let us see the third one, multiplication by a scalar. Scalar means a real number. Okay. So, let f be a function from x to r. Let it be a real valued function and alpha be a scalar, that is a real number. Then the product alpha into f, that is multiplication of a function by a scalar. Alpha into f is a function from x to r. Alpha into f, it is a function from x to r and defined by alpha f of x equals alpha into f of x, where x belongs to the capital letter X, which is a subset of the real number set. Okay, don't worry about the definition. Let us see a question. See, suppose f of x equals x square and alpha is equal to 3. Then what about alpha into f of x, that is the multiplication of a function f by a scalar f, alpha. That will be equal to what? As per the definition, it is alpha into f of x. Okay, alpha f of x is equal to alpha into f of x. Alpha is 3, f of x is x square, 3 into x square, which is 3x square is the answer. Now let us see the fourth one, multiplication of two real functions. Okay, multiplication of two real functions. So you see the product or multiplication of two real functions f from x to r and g from x to r is a function f into g defined from x to r, and it is defined by this equation f into g of x equals f of x into g of x for all x belongs to capital letter X. That is the multiplication of two real functions. F is a real function, g is a real function. Then multiplication of these two is given by this equation f of x into g of x. That is, for example, if f of x is x square and g of x is 2x plus 1, then multiplication of these two real functions, that is f into g of x, will be equal to f of x into g of x. So f of x is x square into g of x is 2x plus 1. When you open the bracket, x square into 2x will be 2x cube plus 1 into x square is x square. So 2x cube plus x square, that is the answer. Now let us consider the fifth one, which is quotient of two real functions, that is division. So let f and g be two real valued functions defined from x to r, where x is a subset of the real number set r. The quotient of f by g, it is denoted like this, f by g. It is also a function defined by, it is a function defined by f by g of x equals f of x divided by g of x. Okay, that is the quotient of two real functions is actually defined by this equation. F by g of x equals f of x by g of x, provided g of x, which is the denominator, is not equal to 0 and x belongs to, the capital letter X. That is, for example, suppose you have f of x as x square and g of x is equal to 2x plus 1. Then what about the division of these two, quotient of these two ratio, f by g of x equals, as per the definition, this is actually f of x by g of x. What is f of x? X square divided by g of x, which is 2x plus 1. Here you see the denominator g of x is not equal to 0, no? Okay, so you see, so this is the answer. And what about the x value? You see, as per the equation, as per the definition, this g of x should not be equal to 0. So g of x means the denominator 2x plus 1 should not be equal to 0. So 2x should not be equal to minus 1. When I take this plus 1 to this side, minus 1. So x should not be equal to minus 1 by 2. That is a condition. Okay, x should not be equal to minus 1 by 2. All other values of x is possible, but x should not be equal to minus 1 by 2. Okay. So in this video, we have discussed about the algebra of real functions. I hope it is clear to you. Thank you.